Hello, welcome to another TeacherTopian tutorial. We're going to be discussing main memory and embedded systems, so like two subtopics, part of topic 3, computers, which is Edexcel GCSE computer science, and the specification codes there are 3.1.1 and also 3.1.3. Now, because of the 2020 specification, you're not going to be asked detailed questions about ROM. You will be asked about something called embedded systems, which ROM is related to, but other than that, you're not going to be expected to know a lot about it. But we do need to know what it is. I think it's prudent for us to know what it is and the difference between ROM and RAM. And they're both primary memory systems. They're both primary memory. And there's something called secondary memory, which we'll look at in another video, such as hard drives, magnetic hard drives, SSDs, optical discs, those things. Those are secondary storage. But primary memory, and the way to remember is it's like, for example, you had our CPU and we're interfacing with our RAM, and we've got the address bus working, we've got our data bus working bidirectionally, looking at locations in primary memory and the data or instructions that are stored in the primary memory, and our control buses sending certain signals to it, what we need to do if we need to send a number to the LU unit, for example. Anyway, let's get back to ROM and RAM. The main things you need to know are, well, first of all, what does it mean? Random access memory. In our RAM, we might have all sorts of chunks of different processes, different applications. Let's say we've got Photoshop here, and we've got OneDrive doing something here, and we might have another Photoshop process here. And it doesn't necessarily matter which order they're in, but they'll have different instruction sets, and there's going to be another concept that we talk about how an operating system decides what to do in what order. But the random access memory location temporarily stores programs. So Photoshop might take the computer might take the Photoshop program from secondary storage, stick it into our primary memory, so that we can interface with Photoshop very quickly when we need to. And that might be the image that we're using in Photoshop in our RAM as well, so it's much quicker for us to work with. And then once we've done saving everything, it goes back to secondary storage. That might be an example of how it might be used. So it would be just too slow to access all of the Photoshop files and everything we need to do from secondary storage all the time. Primary memory is much quicker. And here's the difference here in terms of primary memory that you need to know. RAM is something called volatile memory. And volatile means if you turn off the computer, it loses its information. So it won't, if you get a power cut, if there's sudden loss of power, someone takes the power cord out, then the contents of RAM is going to go away. Which, when you restart your computer or you've turned it off and on again, it might take a while to get everything back to how it was before, or have the program set up again and your web browser tabs all set up again and everything else, because anything that the computer was using in RAM has gone. You have to recompile it back into RAM. So it's volatile. Now, crucially, ROM is non-volatile. And because it's non-volatile, it means it doesn't matter if we turn the device on and off again. Read-only memory, which is what it stands for, read-only memory, can still work even if we turn off the power to our device. And that's super useful because we have lots of household devices. For example, we might have our dishwasher or washing machine, right? And they frequently get turned off, don't they? I mean, or a microwave, we always turn those things off. And they are what we would call embedded devices, or an embedded system. Um, so an embedded system is used to control the function of electronic devices, and they don't need a full operating system. And because of that, they also don't need very fast CPUs or RAM. They don't need to have high clock speeds. They can be very basic in terms of their architecture. And the instructions for them are going to be loaded onto the ROM. Like every time you turn your toaster on, there's going to be a little ROM chip which contains all the boot up instructions. Is an obstruction in the toaster? Is there a shortage? Is there electronical issue? Is there a fuse gone? Whatever it is, there'll be some instruction set which deals with all of those things that we would normally expect to look for. They've got to be reliable, haven't they? I mean, AC units, alarm clocks, and all those. So that's the best way to remember what embedded systems are. They're all the things that you've got in your home. Not necessarily a smart TV, because smart TV is going to have a computer inside it. I mean, they've got some sort of native operating system, and they've got other things. So it's not the best example to use that, but I would stick to things like air conditioning units, washing machines. Like when you turn them off from them, you unplug them and you put them back in, they still boot up and they start up, because all the instructions are loaded into the read-only memory, which is the ROM. Okay, so let's have a look at some exam style questions. So to define the term embedded system, what would you actually write in an exam? It's just one thing, so it's just definition. I think that the easiest thing to do here would be to say performs a dedicated specific task. That would be enough to get you the mark. You could say it forms part of a larger system or another device. So there might be a whole air conditioning eco structure, in an office space or something like that. But I think the easiest thing to do to answer a question like that, it performs a dedicated specific task, because rather than your sort of von Neumann architecture computers, which can be reprogrammable for lots of different tasks, these are just designed to do one thing simply with very little hardware and be reliable. Okay, let's have a look at this question. Complete the diagram of an embedded system by adding labeled boxes and arrows. So make sure you label whatever you do and put arrows in to show one sensor and one actuator that controls a motor. So look, I mean, what would probably trip you up on a question like this is you might go, I don't know what an actuator is. And I don't blame you, it's quite a specific piece of language. They probably use that because when we learn about secondary hard drives, and we've got these hard drives with platters, there is an actuator arm which reads the disk platters. But anyway, you don't really need to know what it is, other than that we've got a controller which would be controlling it. So have the actuator outside of that system. So the actuator might be here, and our microcontroller is going to have the arrow coming out of it with the arrow head pointing towards it. You don't necessarily need to know that it's part of a motor, what that really means, although it's not going to be part of the microcontroller. Now, there'll be some very limited RAM in there, very small amount of RAM. Might be some flash storage, which would be SSD, solid state. So flash is a fancy vocabulary word for solid state. And the central processing unit. It could also be a very rudimentary CPU with not many clock cycles on it and just very simple. Okay, and we've got a battery, so we need to have a sensor, and the sensor is going to be input to this system. So we just put our sensor over here. So our microcontroller deals with the input. Think about the CU, the control unit of the CPU, would decide, okay, what's going on our sensor, where do I need to send the information, and I'll send it to the actuator arm to do something to change a motor. That would be enough, as long as you've put the labels in and the arrows going one way, out, in and out. I think that'll give you the marks. All right, here we go. An embedded computer system is part of a larger machine. State 2 characteristics of embedded systems that make them different from general purpose computers. Right, let's have a look at this. So 2 things. State, so it doesn't say define or describe, so it can just be, you can get away with quite short terms here. There are loads of things you could put in here. There's going to be limited processing, CPU cycles, low power consumption, because some of them are battery operated, right? You could have low cost, because they don't need expensive fancy CPUs, memory, or anything like that. They can be made at much lower cost. They're also a lot smaller in size, less storage. So there's a whole load of things you can hear. Limited user interface. Like I always think of, like, if you've got on your wall in your house, or in your, in school or office, if you've got an AC unit, there'll be a little control panel for it somewhere, and there'll be a whole bunch of things. The things that open the door, there might be a little embedded system which allows the door to open. There's going to be all sorts of things like that you can just observe around you, and your microwave or your washing machine have the very limited user interfaces. Describe how an embedded system that uses a sensor could control car, screen, windscreen, wipers. Okay, so how could we answer this? All right, so it's a 2 marker, so I wouldn't overthink this. How could it control car windscreen wipers? Well, what would actually happen? There might be if set pressure levels stroke moisture, because I'm not exactly sure how these systems work, but it's definitely going to detect rain either from the humidity, moisture, or from the pressure of the water going down, are reached. That's enough for at least one part of that mark. A switch could be either turned on or off. I think that's the simplest thing. And you could also talk about motor speed. Again, actuators and arms and things like that. But you just need to link these 2 things together. You need to have 2 different things that you're saying to get those 2 marks. Make sure the examiner's got 2 things that you can say at any time to get the 2 marks. Don't just say pressure, moisture levels and then leave it alone. Right, I think that will do for this video. Covered enough, I think, there, and some 4 exam style questions. So good luck, and I'll see you in the next video.